Good morning. Welcome to Unit 8. This is Mr. Payne bringing you Quadratic Functions Lesson number 1. Your objective today, you will be able to identify the vertex of a quadratic and choose the correct table values to graph a quadratic. You will be able to identify the axis of symmetry, roots, and whether the quadratic is a min or a max. In your WSQs, don't forget, I should see these key words. I should see the word vertex several times. You should see the word quadratic. That should be somewhat new to you. You should see the words axis of symmetry, roots, and min or max, or minimum value and a maximum value, which aren't new to you, but just new in this context. We have now studied linear and exponential functions. These functions were relatively simple because they were either always increasing or always decreasing for their entire domain. We now will start to study other functions, most notably the quadratic functions, which are a type of a polynomial function. Their definition is shown below. Any function that can be placed in the form of y equals ax squared plus bx plus c, where a is not equal to 0, but b and c can be 0. This is not a new function. We learned how to factor this last unit. Now we're going to learn how to graph it. Read the definition above for a quadratic function and answer the following questions. A. Why is it important for the leading coefficient to be non-zero? The A. Do you see here where it says A is not equal to 0? Well, think about that for a second. If that was 0, would I need x squared? No. So the statement that I would like you to write is, if your coefficient was 0, so if it is 0, then it would be a linear function. Then it would be linear. The ax squared would be completely gone, so all you would have was bx plus c. B. Circle the choices below that are quadratic functions. Well, the first guy is definitely a quadratic because we have x squared. And this guy over here, even though it's not written in proper form, that is definitely a quadratic as well. The others are not quadratics. C. Given the quadratic function, y equals 10 minus 3x squared plus 7x, write it in standard form and state the value of the leading coefficient. So remember that I want my standard form is descending, so I'm looking at my exponents and I want to go down. So I'm going to start with negative 3x squared, then plus 7x, plus 10. Notice that my coefficients, or in my exponents are going down. So I went from 2 to 1 to 0. Now my leading coefficient is going to be negative 3. So my A would equal negative 3. D. If f of x equals 2x squared minus 3x plus 1, then find without using your calculator the value of f of negative 2. What point must lie in the quadratic's graph based on this calculation? So I'm going to plug in negative 2 wherever I see an x. So I have 2 times negative 2 squared minus 3 times negative 2 plus 1. Negative 2 squared is 4. 4 times 2 is 8. Negative 3 times negative 2 is a positive 6 plus 1. That is going to give me an answer of 15. So the point that must be in your calculator is going to be negative 2, comma, 15. Quadratics will still behave in similar ways to other functions. Inputs go in, outputs come out. But they behave differently from linear and exponential functions because sometimes outputs repeat for quadratics. Consider the simplest of all quadratic functions, x squared. Fill out the table below without using your calculator. It's easy. What is negative 3 squared? That's 9. Negative 2 squared is 4. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is going to give me 9. Notice the pattern. Where does my pattern differ? My pattern differs right here. It goes 1, 0, 1. That's the point right in the middle. That is going to be super huge for you to find every time you plug this into your calculator. That differentiation will help you identify your vertex. That is your vertex, or your turning point. The x value of your vertex, is your axis of symmetry. Axis of symmetry. So now I would like you to go ahead, take a moment, and plot those points. Okay, I have mine drawn for you. A couple things that you want to remember is that you always make sure you have arrows, because this continues on, and that this is a rounded edge at the bottom here of my turning point. This here is my vertex. My axis of symmetry is that invisible line that goes down the middle and splits that perfectly in half. That is my axis of symmetry. Now it asks, what is the range of this quadratic function? My range starts at 0 and it goes on forever. So my range is 0, infinity. Alright, now it says using your calculator to help generate a table, graph this parabola in the grid given. Show a table of values that you use to create the plot. I want to give you the table values because you don't have a calculator at home, but you know how to plug this in. Y equals x squared minus 2x minus 8 into your calculator where it says y equals. Your values that you should receive are negative 3, 7, negative 2, 0, negative 1, negative 5, 0, negative 8, 1, negative 9, 2, negative 8, 3, negative 5, negative 2, 4, 0. And the last one should be 5, 7. I know that I created and I went into the other questions, but a couple things that Mr. O and I want to stress to you is that the first thing you have to do here is find your vertex. That's my starting point. That's how I know what I have to graph. We used to tell the kids to go up a certain amount, but because of the Regents exam, that differs all the time. We want you to pick as many points as you can graph. So my graph is 10 by 10, it looks like. So that means I can go up to at least 7. After that, I wouldn't be able to fit it on the graph, so there's no reason for it. So find your vertex, then decide on how many points you need to place on your graph. So now take a minute to go ahead and place these points on your graph. Alright, I have a graph for you. There's my quadratic. It says state the range of this function. The range. Well, I'm going to be starting at negative 9, and I'm going to go up to infinity. This is not new for you folks. This is just a good review. I'm starting here at negative 9, and I go up to infinity. My y's go up for infinity. Now, my domain interval, don't forget my domain is covering my x and my y. If you notice that these continue on forever. So my domain is all real numbers. Oh, let me read the question again. I apologize. Over what domain interval is the function increasing? So my increasing is from here on. So what is that value? That value of my domain is 1. My domain for that value is 1, comma, positive infinity. D says, state the coordinates of the parabola turning point, also known as the vertex, and its minimal point. Well, in this case, my vertex is 1, negative 9. As you can see, I highlighted it in the table. I will highlight it on the graph. That is my vertex. You also may hear the words turning point or minimum value. That is also telling me that this graph is a minimum. How do I know it's a minimum? My vertex is at the bottom. Now it says draw the axis of symmetry of the parabola and write the equation below and on the graph. So I'm going to go ahead and orange, draw my axis of symmetry. And the axis of symmetry is x equals 1. Notice that my axis of symmetry is the x value of my vertex. F, I will highlight in a nice blue color. What are the x-intercepts of this function? X-intercepts. You have heard of these before. They are called your zeros or your roots. So remember that zeros, x-intercepts, the word roots are all the same. And the roots in this case are negative 2, 0, and 1, 2, 3, 4, 0. Exercise 4, the quadratic function f of x has selected values shown below in this table. What are the coordinates of the turning point? Well, let's look real quick. That's my turning point. Notice my pattern. 12, 12, 9, 9, 4, 4. And you should know that negative 2 up here is going to be negative 2 for this value because of the pattern. That's easy to figure out. So my turning point is 2, 13. What is the range of this quadratic? My range is going to be negative infinity to 13. How did I know that? Well, 13 is my highest value. I also know that this is going to be a maximum. All my other values go below 13 in my y column. Just to review real quick your calculator, you will be using the y equals button. You will be using the second button because I will hit graph and I will also hit table. In some cases, you will need to alter your window and your table set later in this chapter. So you may need to remember how to alter those. You'll be using the x squared button often as well in this chapter. Alright, I would like to wrap up with some key vocabulary for the chapter. The quadratic function, let's remember, is ax squared plus bx plus c. That's written in standard form. A parabola will be used for another word for quadratic. Axis of symmetry is the imaginary line that divides the parabola in half. It is the x value of the vertex. Vertex is the turning point of the parabola. Minimum. When the vertex is at the bottom, you have a positive lead coefficient. Therefore, the a will be positive. So my lead coefficient will be positive. Maximum. When the vertex is at the top, you will have a negative lead coefficient. That means your a will be a negative. Roots. Where the parabola crosses the x-axis. Other words where you will hear roots, you will hear the word zeros. Identify your zeros or your x-intercept. Please write all this information down on your WSQs. Thank you and have a great night.